Ladies and gentlemen, please give a big round of applause as we welcome all state ambassadors, Deputy Chief of Mission, United States Mission to ASEAN, Vice Rector of Universitas Pajajaran, and all VIP guests. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Excellencies, distinguished guests, ladies and gentlemen, good afternoon and welcome to the Research Exposition Session Bolstering ASEAN Food Security through Partnership and Cooperation on Agricultural and Biotechnology. My name is Triaji Rizky Ramadan, and it's an honor to be your master of ceremony today. A very warm welcome to all state ambassadors and representatives of the US and ASEAN countries, Vice Rector for Academic and Student Affairs of Universitas Pajajaran, Dean of the Faculty of Fisheries and Marine Science of Universitas Pajajaran, and also all of you who have joined us today. The Research Exposition Session Bolstering ASEAN Food Security through Partnership and Cooperation on Agricultural and Biotechnology is aimed to share the potential and aspect of biotechnology development at Universitas Pajajaran. Once again, I extend my gratitude to each and every one of you for being an integral part of this event. Ladies and gentlemen, starting this event, let us all sing together the national anthem of Indonesia. Ladies and gentlemen, please rise. Thank you. Please be seated. Excellencies, distinguished guests, ladies and gentlemen, this session was initiated by the Faculty of Fisheries and Marine Science of Universitas Pajajaran. So, ladies and gentlemen, let us all listen together to the remarks from the Dean of Faculty of Fisheries and Marine Science of Universitas Pajajaran, Professor Dr. Yudi Nurul Ihsan. The time is yours.
Thank you, Mas Triaji. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Your Excellency, Ibu Kate Rebholz, the Deputy Chief of U.S. Mission to ASEAN. Welcome to our campus. And to all the delegation from the ASEAN country. Your Excellency, the lecturer and student from Universitas Pajajaran, the professor from kind of faculty in Universitas Pajajaran. I will give some of the information to the delegation from the ASEAN that Universitas Padjadjaran is one of the biggest university in Indonesia and also one of the best university in Indonesia. So we have to say welcome to Universitas Padjadjaran. Ladies and gentlemen, today we have the most important meetings. I said this is the most important because we will discuss for our future of our Earth. The population always increase, but in other side the land may be decrease. So we need the breakthrough or innovation to solve this problem. Also we have the problem with the climate. We in Universitas Padjadjaran, actually we have 4 faculty focus in this problem, focus in food security. We have the Faculty of Fisheries and Marine Sciences. We focus in food from kind of fish and marine. Also we have the Faculty of Agriculture. With us, Professor Seno from Faculty of Agriculture also have the focus in food security. Also we have the Faculty of Animal Husbandry, Prof. Siti Badriah also with us, we will discuss about this. And also we have the Faculty of Industrial Agriculture. So I think after this meeting, we hope that we can continue with the other activities. We can have the many discussion, and finally after this meeting, we will have the strong partnership between each others. I think in the future, also with the students from Universitas Padjadjaran, maybe we can something like mobility student or mobility lecturer from our university to other university in ASEAN, and also with the US country, because we need to think how we can serve the food for our population in the future. So I enjoy the discussion, and we will ask to the Vice Rector to open this meeting with the big hope for our Earth in the future. Thank you. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof. Yudi. Next, we would like to invite the Vice Rector for Academic and Student Affairs of Universitas Padjadjaran to deliver the welcoming remarks. Professor Arif Syamsulaksan Kartasasmita, the stage is yours.
Good afternoon, everyone. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ms. Rebholz, Deputy Chief U.S. Mission to ASEAN, colleagues from ASEAN countries representative, the Dean, of course, Professor Yudi, and also other colleagues from agriculture faculty, Prof. Seno and everything, and also, of course, staff, teaching staff, and student. Again, welcome to UNPAD, Padjadjaran University, to our campus here in Jatinangor. It's very honor for us here to have you here, and also the delegate. As the Dean said, that it was honor for us to get some opportunity to have some collaboration with U.S. Researcher and also colleagues from ASEAN countries that representative today come to Universitas Padjadjaran. Of course, maybe I'm the only one here that not familiar with food industries and food securities, because maybe I'm the only one that not belong to agriculture complex in this room. But I think I try to understand that what the Professor Yudi said, that food security and also industries now is becoming very important in our countries. As they did said that the need of food is demanding for increasing, but conversely the land is decreasing. So that's why we have some invention how we can make the good research and also good initiative how we can preserve our food and try to our is in the future. So I think we all know that in UNPAD, I know that a lot of initiative about research, especially in genetic. The Dean said that we have some advancement in the catfish and anything. So we hope that what we learn here can be shared to the colleagues in Asia and respectively maybe some learning learning from the other countries in ASEAN also can be learned from our university in Universitas Pajajaran. So I think that will be our objective today. I hope that our meeting today can get some, some beneficial collaboration between countries, because we have some similarity in our region. So I hope that will be not in the last, but I think this will be some good starting for our the brighter future. I think because the dean asked me to open this the meeting. So on behalf of Universitas Pajajaran, with Bismillahirrahmanirrahim, I obviously open this meeting with the hope that it will be some initiative to see our future will be brighter. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Harif, for warm welcoming remarks. Ladies and gentlemen, we will move to the next agenda. It is my pleasure to call upon the stage Deputy Chief of Mission, United States Mission to ASEAN, to deliver the opening remarks. Please welcome Her Excellency Kate Rebholz. The stage is yours.
Good afternoon. Excellent. I am so excited to be here with all of you. We had a really amazing morning, and I know that this afternoon is going to be just as fantastic. Before I start, I just wanted to thank Dr. Yuri Nurul Ihsan, Dean of Faculty for Fisheries and Marine Sciences. Thank you so much for your generosity here. Vice Rector Arif Samshulak I'm so sorry, I'm about to make a terrible mistake with your name, Kartasasmita. Hopefully that's okay. Thank you so much also for your generosity with us, not just us, the U.S. mission to ASEAN and my American colleagues, but all of my friends from the ASEAN member states who are here today for this exchange and to participate in this discussion. Thank you so much. And then finally, to all of the University of Pajajaran faculty and students, thank you for coming here today. Thank you for participating in this conversation. And thank you, all of you, for hosting us today at this very prestigious institution. It is our honor and pleasure to be here with you. I'm very excited to join representatives from all the ASEAN member states and, importantly, Timor-Leste on this visit. I would also like to congratulate Professor Ibnu Dwi Buwono and his team for all their years of hard work developing the GE catfish that we've all come to see. I look forward to touring these facilities where I understand that you are conducting research that contributes to food security, a critically important issue both to the United States and across all of ASEAN. Southeast Asia is home to more than 660 million people, making up the world's 5th largest economy and one that is rapidly growing. There's vast potential in the region, and ASEAN has a critical role to play in bringing countries together to realize the potential and address really critical challenges. One common challenge that we face is food security. How do we ensure our people have enough access to food for an active and healthy lifestyle? How do we ensure food security in the face of devastating effects of climate change and other obstacles? The United States, as a durable and reliable partner to ASEAN, is committed to supporting the region to address these challenges and secure the food supply and nutrition for the people in Southeast Asia. Around the world and in this region, the United States supports economic growth through development of international standards, including emerging biotechnologies. To strengthen food security in the region, the United States is collaborating with Southeast Asian partners to increase local production, to facilitate trade in food and agricultural products, including seed and products derived from biotechnology. As we witnessed during the supply chain disruptions caused by the COVID-19 pandemic, international conflicts alongside climate change, and more extreme and frequent weather events, facilitating trade and increasing agricultural productivity are key to bolstering food security. Agricultural researchers like you are the unsung heroes of the world's food security. Thanks to you and your work to increase agricultural productivity. Amazingly, we're still sustaining the world's 8 billion people today because of the achievements of past researchers of the Green Revolution. And you and your colleagues back in your home countries are now continuing and expanding that legacy. I hope students in the room today will be inspired by the upcoming presentation to carry on that torch into the future. Yesterday, the ASEAN delegation learned from international experts about biotechnology achievements from various countries outside of ASEAN. And today, they're learning from one of their own and seeing the benefit of biotechnology in action. Indonesia is at the forefront of agricultural biotechnology research and development in the region. I learned so much this morning about GE potato that is resistant to dreaded potato blight. This technology will drastically cut down on the amount of toxic fungicide used, directly benefiting farmers by lowering input costs and reducing health risks. I look forward to further hearing this afternoon about the rapid growth GE catfish that will lower feed and input costs and reduce the rate of fish depletion from overfishing. What we're seeing today are concrete examples of how we can leverage biotechnologies to meet regional and global challenges together. In closing, I would really like to say how much I've enjoyed sharing this morning's program with you, and I am thrilled to continue to share the program this afternoon. I'm so proud of the U.S. support for ASEAN's Agricultural Biotechnology Workshop, which is all about what ASEAN and the ASEAN-U.S. partnership can achieve. And before I close, I did just want to acknowledge my fantastic colleagues, Ray and Jasmine. Can you wave to everyone briefly? They have done an incredible amount of work to make today's program a success, and so I thank you, my colleagues, for everything that you have done. To all of you, through continued cooperation on biotechnologies, we're strengthening food security for our combined 1 billion people. I'm incredibly excited about the future of ASEAN and US-ASEAN cooperation. Thanks to all of you. Thank you.
Thank you very much. We kindly ask Her Excellency to remain on the stage, because before we move to the next session, there will be an awarding the souvenir from Universitas Pajajaran. The souvenir will be presented by the Vice Rector for Academic and Student Affairs of Universitas Pajajaran. Ladies and gentlemen, the special souvenir given by the Vice Rector of Universitas Pajajaran is a replica of a traditional weapon originating from West Java, or commonly called kujang. Thank you very much, Excellencies. You may return to your seat. Ladies and gentlemen, next we will take a photo session. Untuk itu kami undang Bapak dan Ibu sekalian untuk dapat berdiri dari kursinya masing-masing karena kita akan melaksanakan sesi foto bersama. We kindly ask you to stand up to take a photo session. Sekali lagi kami undang Bapak Ibu dan juga rekan-rekan mahasiswa untuk dapat berdiri dari kursinya masing-masing dan juga merapatkan barisan karena kita akan melaksanakan sesi foto bersama. Okay, the second one, Unpad 500 dunia, Unpad 500 dunia pose. Thank you very much, please have a seat. Excellencies, distinguished guests, ladies and gentlemen, as we mentioned earlier, this activity is aimed to share the potential and aspect of biotechnology development at Universitas Padjadjaran. Continuing this momentum, it is now my distinct pleasure to present the main agenda of the day. Ladies and gentlemen, allow me to welcome our moderator, Head of Internationalization Unit of the Faculty of Fisheries and Marine Science of Universitas Padjadjaran, to introduce the next session. Ibu Fitri Meglarawati Prawitiwi, PhD, the time is yours.
Okay, check. Okay, good afternoon, everyone, ladies and gentlemen, especially for Dr. Kate as Deputy Chief of U.S. Mission for ASEAN and the Dean, Dr. Yudinur Isan. So, ladies and gentlemen, before we start, I want to welcome you, especially from Asian representatives. So maybe when I called your country, you can wave to the audience. Okay, so representative from Brunei Darussalam. Okay, give applause. And representative from Cambodia. Okay. Representative from Lao People Democratic Republic. Representatives from Malaysia. Representatives from Myanmar. Okay. Representative from Philippines. Representative from Singapore. Representative from Thailand. Representative from Vietnam. Representative from our younger Asian participants, Timor-Leste. Okay. And of course, representatives from Indonesia. And also as well as representatives from USA and Canada as well. So on behalf of Universitas Padjadjaran, thank you so much to come to Universitas Padjadjaran. And of course, among us here, we have also professors, and in the backside, we have students as well. So on behalf of Universitas Padjadjaran, it is a pleasure to welcome to 2024 U.S. Embassy event during the campus visit to the workshop of bolstering food security through partnership and cooperation on agricultural biotechnology. So together with the organizing committee, we have put great effort into a planning of memorable events to discuss them of food security, especially in agricultural biotechnology. So without further ado, we have speakers, special speakers from Indonesia, from Universitas Padjadjaran, to share recent findings on design of transgenic mutiara catfish growth hormone for the production of superior fingerlings. So if in the morning you learned about GE of potato, so today you will learn about GE of catfish. So, Prof. Ibnu Dwi Buono is a professor of fisheries biotechnology, the Faculty of Fisheries and Marine Sciences. He completed his doctoral at Universitas Padjadjaran and specialized in aquaculture, biotechnology, and fish genetics. And his recent research over the past 8 years focus on transgenic mutiara catfish, and it has resulted 6 publications in high reputation journals. So please welcome Professor Dr. Ibnu Dwi Buono. Please come to the stage. Okay. So beside Prof. Ibnu Dwi Buono, we have another speaker. Actually, he is my colleague, because we both work in the same project as Professor Ibnu Dwi Buwono supervised. So we have Dr. Rafi Grandiosa as a lecturer, researcher at the Faculty of Fisheries and Marine Science, and his expertise in fish genetic, biotechnology, aquaculture, and fish disease. Dr. Rafi, please come to the stage. So, ladies and gentlemen, I hope you can enjoy this research exposition session as much as you enjoy the high-speed train from Jakarta to Bandung or something, or enjoy Indonesia as well. So, without further ado, I will hand the mic over to Dr. Rafi to explain a little bit in details about our project, especially in GE of catfish, in Mutiara catfish. Please, Dr. Rafi, time is yours.
Good afternoon, everyone. Welcome to Bandung, Universitas Padjadjaran. Your Excellency, Dr. Kate Remholz, welcome, and honorable guests from Asian countries, US, and I'm very delighted for your visit to our faculty, to our university. So actually, the session here is a presentation from our innovator, Professor Ibnu, and delegated to me, and we will visit the fish, don't worry, after this. Yeah. We won't take too long here. Just, what you call it, the title for the presentation today is about the catfish, yeah, the transgenic catfish. So, wait a minute. Yeah. So this project is led by Professor Ibnu Dwi Buwono since 2015, and I'm a member of his research along with Dr. Fitri and Bu Dr. Yuniar Mulyani. Okay. And next, yeah, of course, transgenic fish. The first thing is to concern is that transgenic is not a new thing. It's already a subject three decades ago. So here we developed transgenic catfish since 2015, and of course, continuing from the speech by Dr. Kate, it's important to support research to support food security, because aquaculture, there's many challenges. One of them is the growth of fish, and one of the important fish species in Indonesia in the freshwater is catfish, along with carp and tilapia, yeah, you may know, yeah. And then we decided to develop the catfish with a better growth, superior growth. Okay. So one of the main concerns that comes upon this is the food safety, because not everyone is what you call aware or scared to eat transgenic product. But this is a publication by Dunham in 2004 from a book, Aquaculture and Fisheries Biotechnology. It is, what you call it, it is stated that 2004 publication, it is not hazardous to human health if there is a certain gene inserted to the fish. So another thing happening in the US, in the Canada, is the genetically modified salmon. So I think the GM salmon is cultured there and produced in a specific site. And there is some kind of legislation, of course, in the country. But again, it is concerned safe. And if it escapes the wild, it cannot reproduce. There's no viability if it's escaped to the wild. So we come to another freshwater species, the transgenic tilapia. I think this is Sabagulen et al. And again, the team research proven that there's no environmental implication for the introduction of transgenic tilapia, and even it's very safe to consume of transgenic tilapia with tilapia GH hormone gene, and it's very important as alternative feeding source in the future, I guess. Yeah, and then we come to another freshwater species, the common carp. This is another aspect. Other than the food safety, another aspect is the concern, the escapees to the wild. But again, transgenic fish, it doesn't have the ability to expand population if, in case, escape to the wild water. Now we come to the catfish. This is Clarias garipenus, and this is the achievement of Professor Dr. Ibnu Buwono. And we researched this. We already have the 6th generation now. So the 6th generation means we have observed the growth rate in every generation. By the 3rd generation, it's already have 3 times higher growth. It's very interesting. Compared to salmon coho, so it's have a 10 times growth rate, and tilapia, yeah, 2 to 7. What we have done here is the main science is that we inserted the growth hormone exogenous gene from Clarias garipenus, isolated from Clarias garipenus, and then we delivered it to the next generation by using electroporation in the next slide, integration into DNA, and then the final product is overexpression of growth of the growth hormone. Yeah. So it grows faster. And this is a real photo, yeah, Prof. Ibnu, yeah, from your research. And yeah, okay. The mechanism, maybe it's different from the plant, or because in the fish it has what you call it, a spawning outside of its body in the aquatic. Yeah. So the main scheme is we have to fertilize the sperm with inserted genes into the eggs, so it could be fertilized until it becomes embryo, and then if it's successfully fertilized, it will become hatch transgenic larvae. That's the concept since 3 decades ago. But what we approach is in using sperm electroporation method. So this is the most efficient way, but this could be a little bit technical for my beloved student, because yeah, we have to construct the gene. We isolated the gene, and then we constructed, and then we transferred it to the sperm using electroporation method, using a vector, the CMV vector, a virus. Maybe Professor Ibnu can collaborate on that. And then the sperm with inserted genes, we can see here, we inserted by using electroporation. And then, now this is the interesting thing, 98% was fertile and could become a larvae. Yeah. And then we keep the larvae until it become a broodstock. Yeah, a broodstock. That's the founding broodstock, the G0. Now we have the G6, so it's already since 2015. Yeah. And then how do we clarify it has the inserted gene? We use a classical PCR with to detect the GH gene. So now we have the Lele Mutiara supergrowth. If you're asking what is Mutiara, Mutiara is a strain of a catfish. Yeah. It's already improvement of Clarias garipenus, but we want to improve it even more by using transgenic method. Okay. So I think this might be technical. Maybe Professor Ibnu later will collaborate on this. But we have isolated the genes from the brain of the Clarias garipenus, yeah? and then we inserted to a factor, and it's successful. That's the main thing. So, as I told you, the founding population is the G0 was developed in 2015 and 2016. And then we bred those founding population, and then we had the G1. It showed that it could transmit the GH exogen until 42.85%. And then even further in G2 and G3, we have an increase of transmission. Is it true, Professor Ibnu? Yeah? Increase of transmission, yeah, in each generation, yeah. So we had the G1 in 2016 and 2017, yeah. And then we also always clarify the gene inside the fish, yeah, by using PCR method, yeah. So now the growth is caused by, how do I put back? Oh, yeah. The growth is caused by overexpression because it has an inserted GH gene. We call it CGGH because it's abbreviation from Clarias gariepinus growth hormone. So now we have here the schema is already at G4. It's already transmitting 80% of the CGGH. Yeah. So this is our research, and we have kept the fish. This is the interesting thing. In a small lab, yeah, in one of our lab, we will visit there. We have time later in a indoor hatchery. So it is not sold to the market. It's only kept in our facilities because we still have meetings with the government to discuss about the transgenic future, yeah, of the fish. But from our research, it's very interesting because compared to non-transgenic, we have higher growth, higher also food conversion rate, and also the weight also is higher compared to the control. Yeah, the control is the DNTG, and then also the density of the pond is also affecting the growth. But in general, there is an increase of growth compared to the non-transgenic. Okay. So now we look at the gonad. The gonad is the organ which contains the eggs of the fish. If we compare that to the non-transgenic, we could see different texture or color. Yeah, is much more ripe, and also it's happening also in the transgenic male catfish. So we can see comparison different color and also maybe higher eggs. And then that was after spawn, yeah, this one, yeah, the G1. Okay. Now, the main concern of the transgenic fish is actually the food safety. Have anyone here consume transgenic fish? Maybe Prof. Ibnu every once a week, maybe. Yeah. Yeah. But he's the innovator, so he doesn't. And I also consume too, sometimes. But actually, the main thing is that we have to see that the concern is, do you remember the previous slide? The factor of the gene for the insertion to the sperm, yeah? It's the CMV, the factor, and SV40. We don't want it in the fish, yeah? So we detected using biotechnological methods, and it's not there, yeah? So it's perfectly safe. Unless you eat it raw, it's not safe for you. It must be perfectly cooked, yeah, the fish, yeah. And I mean, you can fry it, you can dibakar teh apa ya, dipanggang, yeah, grill, sorry, grill, yeah. So and then we have our lab members, of course, we test the food to our lab members, test of food, and then I think the consumer acceptance is quite high and quite satisfied compared to the control fish. And then I think the flow chart would be if we continue this project, we have to see if it's really safe before commercialization and mass production, and at the end we have to have a certification for this product by the quarantine or BPOM or other institution. Yeah. Okay. Okay. And then we use how did we detect CMV with traditional PCR method using certain primers. This one, the primer, yeah, CMV forward, CMV R. And we could detect, we could see that there is no indication of what you call it, the CMV in the in the selected samples. Okay, this is the what you call it, the flavor test of the transgenic. Transgenic is with the category of very good, good, average, normal, and not good. Yeah. The transgenic fish seems to have a higher acceptance, yeah, regarding the aroma, the texture, and the taste. Okay, and we have the, because it's safe, because it doesn't contain CMV, we test it to the students. Yeah. Okay, that's the main thing. But then, yeah, another thing we have to remember: is it allergic or not? So we have allergic test, yeah. Of course, we have to approach from different aspects. Now we have the allergic test. I think that with biochemical test assays, we could see that the histamine is quite low in what you call it, in transgenic fish. Here we can see the non-transgenic is higher regarding the histamine. So there's no the cause for allergic is histamine, right? Yeah, this lower. Yeah. And then we come to current status of research. The interesting thing is that we are still running this. We still, if Professor Ibnu is still here, there is still transgenic fish, catfish. So we are currently doing research regarding the effect of photoperiod and the temperature, and also later Bu Dr. Fitri will study about the immune aspects of the transgenic, and Ibu Dr. Yunyal Murilyani also will other physiological aspect, yeah, because we have to really discover the potential from many aspects, yeah, from the what you call it, gene expression of this fish. So I think the time is very limited. I would like to talk more, but it's very limited. And thank you all for coming, my students and fellow colleagues, professors. It's an honor for me to stand here. It's my first time actually. And I think I will give it back to moderator, and maybe Prof. Ibnu will maybe share something also, share his what you call it, his knowledge and his experience during his research. There's many things going on in research. Sometimes the water is not flowing, yeah, electricity stop like that, because everything can happen. But we already have a formula, and it's continuing. Our research is always funded every year. We always have funding every year. That's the most important thing. I think. Thank you so much. We will visit this, my friends here. And then, thank you. I come back to Dr. Fitri. Thank
you. Okay, thank you, my colleague, Dr. Rofi, for a brief and great explanation about our project, especially for transgenic or GE of Mutiara catfish. I hope that you can understand a little bit about catfish. Yeah, But if not, maybe in the next session we will visit the hatchery. So you will face with the fish, how big and how cute the fish. Okay, so maybe we have very limited time today, so we will open for discussion, question and answer session. If you want to ask something, please raise your hands. From representative from Asians, or maybe from students as well. We're very happy. Okay, yes, please, Mr.
Yep, thank you very much for the presentation and congratulations for the result on Tanzanian catfish. I have two small questions for you about the technician of the transformation. So normally when we do with plant transformation, and we have some method to select Tanzanian plant, but I would like to ask you which kind of method you use for selection of Tanzanian catfish. That is the first question. The second question is that for plant transformation, we use self-fertilization to have a next generation for Tanzanian plant, but I don't know which method you use for catfish fertilization. You use sperm from Tanzanian catfish, or you use sperm from white Thai catfish for fertilization. So that is two questions. Thank you.
Okay, thank you, Mr. So yeah, we have a questions regarding the methods and also the fertilizations, maybe methods, about the methods of selections, maybe. Okay.
Yeah, thank you very much in your question. I talk to Indonesian language and translated Dr. Rofi or Dr. Fitri. Nah, terima kasih Bapak dari Vietnam ya. Nah, metode untuk fertilization di ikan transgenik itu pada dasarnya sama dengan yang di ikan non transgenik. Ya, namun dalam seleksinya ini yang menjadi syarat khusus. Jadi ikan transgenik harus di broadstroke-nya, induknya harus diverifikasi dengan PCR, di mana harus ada amplikon fragmen sebesar 600 base yang tadi adalah sisipan Clarius garipenus growth hormone, CGH insert. Nah, itu harus ada dulu. Jadi seleksinya sebenarnya lebih mudah. Dan ikan transgenik ini lebih mudah digunakan untuk membentuk kalur murni, pure strain. Kalau non transgenik susah. Kenapa? Kalau non transgenik kita susah untuk melihat strainnya ini, karena kan strain itu kalau karakter unggulnya itu multi, itu akan kesulitan membentuk pure strain. Tapi kalau ikan transgenik mudah, tinggal diverifikasi di insertnya. Jadi pemuliaannya mudah. Jadi pemuliaannya saya tinggal induk, misalnya 5 induk, berapa yang transgenik? 1, supaya induknya nggak mati, prosesnya tidak mati, kita ambil 5 ekor, dipotong sampel sirip ekor. Ketemulah insertnya, udah. Misalnya 2 ekor jantan betina, udah jadi nanti. Banyak Pak, itunya Pak, apa namanya? Telurnya banyak sekali. Tadi Bapak lihat konat lagernya itu banyak sekali. Jadi saya luar biasa karena sisipan itu kan ada 2 kopi ya di ikan non transgenik. Itu akan meningkatkan jumlah sel proliferasi. Jadi itu keuntungan transgenik sebenarnya. Dan transgenik mudah membentuk kalur murni unggul, superiority. Nanti kita bisa bicara mengenai transgenik homozygous. Nah, saya kira itu. Nah, mungkin bisa ditranslate ke Pak Dr. Rafi. Silakan.
Okay. So the selection of the broodstock is based on the detection of the gene. So we cut the tails, the fin. So we have to verify if there's the gene or not. And then, as said by Professor, it's more easier compared to normal non-transgenic because we already targeted the CGGH. So we detect using PCR the CGGH. So we just pick randomly the male and the female, and then we mate it. And coming to the second question, how do you fertilize it? So in plants it's different. So we have the sperm is released into the water, right? So we just do artificial reproduction. So we have to stripping the female fish. So now it's the interesting thing. The transgenic is from the male. So the sperm is introduced to exogenous gene by electroporation method. So we do not modify the eggs, except we have the G1. It's already inherited from the founding, the G0. So then we have the desired product.
Ya, saya tambahkan Pak ya. Jadi kalau kita pembuatan ikan transgenic itu hanya satu kali Pak. Step 1 berhasil, yang lain itu melalui reproduksi secara alami. Jadi induknya aja disuruh kawin. Kan sudah memarisi transgenik, tinggal berapa transmisinya G1, G2, G3 pasti meningkat. Nggak perlu setiap generasi kita mau produksi menggunakan electroporation. Waduh, lama itu. Susah Pak, electroporation belum tentu berhasil. Saya 10 kali injection ke sperm gagal, hanya 1. Tapi 1 sudah bagus, berhasil kita. Ya, mungkin ditranslate Bu.
Okay, so we insert the genes only on the first generations of this fish. So we didn't do for the second, third, and fourth, and until the 6th generation. So they can naturally happens for the 6th generation. So we think that the genes insertion only at the first generations, something like that. Okay. Maybe, okay. So another questions maybe from this side?
Thank you for the opportunity. It's very interesting project, Dr. Prof. Ibnu. Congratulations. I have a question actually. You mentioned that the first one is from where did you isolate the gene? Yeah. Is it from also the catfish or from other fish? Is it the fish is commonly expressed? Because you do overexpress gene. Then how you differentiate whether, because if it's already in the fish, and how you know that is because it's already in the fish? Because we in the plants, normally we use a promoter as a indication it is a transgenic or not. Thank you.
Thank you Bu Dokter ya. Temen lama di Bali Vet ya. BP Biogen. Sudah lama ketemu dan beliau ini adalah ponakannya Prof. Dance. Kalau saya ponakannya Bu Prof. Rostita, jadi supaya tahu, saya itu ponakannya Bu Rostita. Dari peternakan juga. Nah ini kelihatannya kita itu menarik ya, banyak transgenik. Saya sendiri sebenarnya sudah takut bermain di transgenik Bu. Dulu orang penerimaannya itu selalu transgenik itu ikan yang berbahaya. Ikan yang kalau masuk ke perairan alami itu kan menjadi predator yang buas. Betulkah itu? Nah saya buktikan. Nah saya mengisolasi dari gen ikan lele dumbo, strain dumbo. Dumbo ada 4 strain yang di Indonesia yang kita kenal. Strain Dumbo itu sebelum lele sangkuriang dirilis ya oleh BBAT, kemudian strain Mutiara. Nah, strain Mutiara ini kan sebenarnya yang meriliskan BPPI Sukamandi. Nah, saya mengisolasinya dari Dumbo, lele Dumbo. Antara lele Dumbo, strain Dumbo dengan strain Mutiara itu nggak sama. Jadi nggak bisa disebut apa homogenes, nggak bisa. Itu saya buktikan dengan sequencing GH. Itu hanya kemiripannya sekitar 54%. Jadi sudah beda. Karena Mutiara itu kan hibrid dari 4 strain. Tapi yang dulu nggak jelas juga. 4 strain yang dibikin BPPI Sukamandi, ya udahlah. Ya saya bikin strain baru yang Mutiara. Nah, ini saya masukkan. Jadi saya spermanya lele Mutiara, saya isolasinya dari hipofisa pituitari dari ikan lele Dumbo. Nah, kemudian saya cloning. Saya cloningnya di tempatnya Ibu Prof. Ali Melani di lantai 6 molekuler sendirian tahun berapa itu, 2000 berapa saya lupa. Saya masuk labnya itu dites dulu itu sama Prof. Ani, kalau nggak bisa lu nggak bisa ngerjain ini di sini. Wah, galak banget ini. Nah, tapi saya saya harus bisa. Akhirnya saya cloning di sana sama Bu Yuniar. Cloning di sana, dapatlah GH-nya. Kemudian saya masukkan. Tapi transfernya Unpad nggak punya. Makanya saya bilang, Prof. Setiawan yang dekan Paca ya, kalau mau main kontrak vektor transgenik, persyaratan untuk saya harus ada elektroforasi, chain pulsar, pioret ya. Nah itu Bu, yang ada cuma di sana. Udah, kita berangkat di sana. Nah di sana berhasil Bu. Yaitu tadi berapa kali itu berhasil, alhamdulillah masuk. Nyisipkan itu yang susah Bu. Kan kita bawanya itu harus vektor yang sudah jadi. Yang sudah jadi Bu, artinya ada promoternya PCMV, itu kan sebenarnya gini Bu. Vektor saya itu, vektor accretion vektor, itu punya mamalia. Makanya, kok nggak ikan Pak Ibnu? Alah, udah saya cobain ini aja dulu. Ternyata berhasil Bu. Nggak ada masalah, vektor mau dari mamalia, mau dari fish, tina naon. Nah saya masukin di situ, berhasil. Sebenarnya saya punya 2 rekitan, yang satu promoternya beta aktin, itu nggak berbahaya, fine-fine aja, itu Prof. Alim kan yang, saya justru pakai PCMP, PCMP itu kuat Bu, PCMC itu bukan promoter virus, bukan, walaupun dia itu sebenarnya sekuen yang bisa menginduksi kanker serviks. Bukan, dia itu sekuen parsial, bukan gen penyandi. Nah kalau sudah ditranskripsi, dimasukkan ke dalam sel sperma in vivo ya, udah dibuang promoter itu. Jadi sudah terintegrated di kromosomnya, gak ada masalah. Saya makan Bu, sampai generasi 1. Enak Pak, ikannya dagingnya tebel, nggak usah pakai ini, fine-fine aja. Bahkan saya mati enggak ya saya ya. Kalau mati ya enggak apa-apa lah. Ya orang tahu bahwa saya mati demi penelitian gitu. Ya. Ya, terima kasih. Nah gini Bu, saya buktikan, jadi gini, pada generasi ke-1, ke-2, tadi kan sudah ada deteksi residu ya, residu PCMV. Oke, PCMV masih ikut ya, tapi generasi berikutnya habis sudah nggak ada. Berarti yang terintegrasi sebenarnya adalah si CGGH ya, promoternya ikut promoter DNA inang. Ya. Jadi kalau dinamakan aman, masa sih orang nggak percaya? Emangnya orang itu pengen percaya terus saya mati gitu? Itu kayaknya itu. Jadi janganlah kita itu riset ini dibuat. Saya riset itu mentaruhkan nyawa loh Bu. Saya datang dari sini ke Eijkman, pulangnya jam 9 malam, nggak ada orang di sana, itu banyak hantunya katanya. Itu Bu Prof Ani aja tahu itu. Itu aduh minta ampun lah. Ya terima kasih. Ya, silakan. Pak Rofi.
Okay, that was a long conversation. sorry.
Because they are old friends.
But the underline is what you call it, taruhannya what? He risked his life by eating the transgenic fish. So applause for Professor Ibnu. Because nobody has eaten transgenic fish before. So what she asked, Professor, she asked, where did the isolation come from? It's from another strain called Dumbo catfish. So the other part was technical, I just lost my mind. But I have a sign, so it's quite limited, but I think the time is quite limited, and I think everyone is still interested here, but I have to give it back to moderator, Dr. Fitri.
Yeah,
Sorry
maybe
about
we
that.
can discuss later in the hatchery. So, yeah, it's better to know and see how the fish. So, I'm sorry, participants and also students, we have to end this sharing session. Is very, very limited time. Maybe in another opportunities, we have a long time to discuss more about the GE of Mutiara catfish in biotechnologies. So if I can conclude here that the design of transgenic Mutiara catfish growth hormone holds promise for enhancing the productions of superior fingerlings. And it can be one of the potentialities to address food security concerns. So, and also I hope you guys to meet in this meeting. We can still collaborate, communicate in the next future. Thank you very much for your attentions. So enjoy your times. After this, we will move to the hatchery, and you can see the reel of GE catfish. Thank you. Good afternoon. Thank you, Prof. Ibnu. Thank you, Dr. Rafi. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much. Ladies and gentlemen, please give a big round of applause once again. Excellencies, distinguished guests, ladies and gentlemen, now we've arrived at the end of the research exposition session bolstering ASEAN food security through partnership and cooperation on agricultural and biotechnology. Thank you for joining us today. I'm Triaji Rizky Ramadan signing out. Wassalamualaikum warahmatullahi wabarakatuh.